Let's talk with Tommy Dangerous. Well, Tommy Dangerous is the co-founder and CEO at Mage. Additionally, Tommy has had 3 past jobs, including the prestigious head of marketing and promotions platforms at Airbnb. Now we've got him on the MLOps.community Meetup. I hope you didn't expect anything else from this little musical intro today. Tommy Dangerous, I'm gonna bring you on. I gotta say hello. And welcome to the show. What's up, dude? How you doing?
Doing fantastic. I was up late last night preparing for this, but that little tune, it got me feeling like I'm in Hawaii about to go surfing. So I feel
I just
great.
want to put
Thanks
you
for
at
having
ease,
me.
let you know
Yes.
the vibe before we jump into this. I know you got a lot planned for us, and I have to say, every time I would read the title of today's talk / meetup / coding session, I always thought about Outcast.
Yes.
I don't know why.
Exactly. Yes.
Did you do that on purpose?
Yes.
You did. Okay, there we go. I like it. So, just so everyone knows, we're not alone here. We've got the trusted partner and sidekick, Ben. Look at him. I just brought him on the stage. What's up, man?
Hey, how's it going?
Good. So, I'm going to let Tommy get cracking with the first talk / you're going to actually do some demoing. There's some GitHub repos that people can follow along with, right? And
Yep.
so we'll drop some links in the chat for people who want to follow along. Please, if you have any questions, throw them in the chat right now. We will be monitoring that, and then either Ben or I will jump in and stop Tommy, and we'll ask the question and then keep it rolling. So let's get into it, man. Without further ado, I'm going to hand it over to you, Tommy.
Thank you so much. Super excited to be here. Thanks for having me. And thank you everyone for waking up early, late, wherever you are in the world to tune into this. So, real quick, what is Mage? Mage, it's an open source tool it's a code editor, helps you transform your data and build ML pipelines. It's open source, so it's on GitHub. I shared the link, but we'll walk through this. And so today, what I'd love to show with everyone is a setup, what it can do. We'll walk through a live example. It's a mix between like a notebook and a text editor. I don't really like using those two words, but for really quick understanding what it does, it takes the best of both worlds. So, what are notebooks good for? Some of you might use notebooks for explorations, visuals, or maybe sharing things out, writing throwaway code. You get that interactivity, that part of the notebook is really good. What's some good things about a text editor? You can write scripts, you can write really clean code, review is really easy, versioning is really easy. And so Mage takes a little bit of best of both and tailors the user experience specifically to help you transform your data, help you build machine learning models, to reproduce that code, write modular code, built in really good software engineering practices. So let's go ahead and just jump right in. So you can set up Mage really easily using Docker or just with a pip install. And then you would initiate a project. So I created a new project called MLOps demo. And I did this all in my command line. And then you just run Mage start. and it runs on your local host, or if you're running it in the cloud, it'll run on whichever IP and port that you want it to. So here I created a pipeline. I created a project called MLOps demo. I created a pipeline called Titanic Survivors. It's empty right now. So first, before I jump into any project, I might want to play around with some things, like type something in the blog just to make sure the kernel is running. Awesome. I might want to, write some, load some data. So let's say our project is we want to take a look and explore the Titanic survivors or people that went on Titanic. So let's go ahead and fetch some data. So here, okay, so I got to import some libraries first. Awesome. Let's go ahead. And this is going to be a coding experience. So, if people have questions, please just stop me and ask any questions. But first, okay, we fetch some data. Let's look at the data. What's inside this data? All right, let's do some pandas real quick, and we'll look at the data frame. IO, okay, import IO. Awesome. Okay, so we got one, some nice columns here, some good data. Okay, this looks about right. This is the data that I want to load. So before we even continue, every cell in this editor, you got transformers, data loaders, exporters, scratchpad. Well, actually, the transformer, data loader, and exporter, those are all mapped to an individual file. Now, scratchpad, think of scratchpad as throwaway code or just stuff that you want to experiment with. And so I have a scratchpad here. I'm just making sure my code works. But when I'm ready to put it into a modular reusable file that I want to commit in my code and actually reuse in production, I now go ahead and build a data loader. So let's call this data loader load Titanic data. Load Titanic data. Cool, update that. Let me go ahead and just copy paste my code in. And then I can just run this. Awesome. So now I have this block of code, load Titanic data, and you can see here in my data loaders, there's a Python file, and it looks exactly just as is right here that loads that data file. Now, what's great about this is it's modular, so it's reusable. I can also unit test it as well. And I help my fellow teammates I help them help me. Imagine code reviewing this, and I'll show you what it looks like later in a pull request. Have you ever tried to code review someone's Python notebook? It's you kind of want to pull your hair out. It's so hard to track. But here, really easy. Awesome. So now I got my data loader. Now I'm done with this block. I can delete this. Now what's also awesome is it's very data centric. So I have this data loader. It returns a data frame. I can dig deeper into the data set. I can look, I got these nice little charts. I can see some distribution. I got some reports. Okay, so I got some missing cells here. I got, almost complete data. Now let's look at some graphs. I see, okay, everything has 100% complete data. Oh, embarked, age, cabin, those are missing. So maybe we want to clean that data up a little bit. Okay, so let's go ahead and let's do the next part of our pipeline. So now we have, one block in our pipeline. So the next one I want to do is, now I can start imputing, I can start doing some feature engineering, but I want to do some reusable blocks. So first is I'm going to extract out the different types of columns, because when let's take a look first. We can look at some feature profiles here. We see we have a mix of numbers, binary columns, and text columns. I have different types of transformations I want to do on these sets of columns. So I can do them all in one block, right? So I can create a transformer block, do it all in one block, but then I would have to hard code some columns in there, and that wouldn't be too reusable. So let's go ahead and let's create a transform that extracts all these different columns out. So first I'm going to add a transformer. And what's great about this is I can set this to depend on this data loader. Okay, let's call this one extract number columns. And I know my number columns. I looked here and I saw that I had age is a number, siblings, parch, etc. So I got that there. Now I can run this and look at that. Extracts all the number columns. Awesome. I'm going to do the same thing for the string columns. So here, let's paste that in. Let's have it depend on that. Let's run it. Awesome. It's looking good so far. And then finally, my binary columns. So binary would be, has 2 values. So if we look actually at this one, we know survived is binary, has 2 values, and then sex is binary. So let's go ahead and add that. And you'll see why we're doing this. Let's run this. Perfect. So now I have 3 blocks that extract this type of information now. Now, let's go back to, we were looking at, let's say this one right here, Icy Bird. Oh, we forgot to name this. So this was extract number columns. Awesome. So we look here and let's look at some reports. We see that age is missing. Let's go ahead and create a reusable block that imputes numbers. All right, so let's go ahead and add another transformer. Let's have it depend on extract number columns. And then what we'll do here is we will, now in a real scenario, we might want to, am I back? I'm back. Okay, we might want to use different imputation strategies, but for now we're just going to do median for everything. So here let's call this impute number columns, and then let's run this. Let's see what happens. Awesome. So then now let's look at some charts. Okay, everything is filled in. Amazing. Okay, so then what's next? I know, let's look at the text columns, extract text columns. Let's see what we got here. Oh, sorry, let me refresh this real quick. Okay, so we got this. Text columns, embarked. Oh, all the text columns have data, but this one column is missing a little bit. Let's go ahead and impute and fill that in. So here we'll have this get its data from the text columns. And what we'll do is we'll just do something simple. We will just fill in missing. So let's go ahead and do that. And ta-da, now we have really complete data. Awesome, 100% complete. So far we have low Titanic data, we have all this. So, before we go on, let's go ahead and just, let's commit some code, because this is quite a bit. Or actually, let's execute our pipeline to make sure everything's running. Awesome, everything's running. So now I'm gonna commit some code and just to start it off, I'm gonna create a branch called init, and then my first commit. I'm typing in a terminal behind the scenes. First commit. Of course, in the real world, we'll have more descriptive PRs. But let's go ahead and jump over here. Awesome. Now let's take a look. Okay, so instead of a giant Python notebook, we can see, okay, I have load data. Awesome, I can see it's trying to load data. And then this is some metadata around the pipeline. And then here's look how clean this data is. My goodness, so easy to read. It'll make anybody on your team jump out of their seats to be like, I want to review this PR. Awesome, cool, it looks good. I'll just stamp my own PR and then let's merge it. Okay, let's go ahead and continue now. So we'll go down here and now we have impute. Let's rename this impute text columns. Got it. Now, before we train, we need to actually do some encoding. So let's go ahead and write a reusable encoding block. So I'm going to do transformer. Let's encode the binary values first. So there's a column called survived. It actually is 1 and 0s, which is great. It's already encoded. But there's one here, male and female. It's not encoded. So we'll want to write a reusable encoder for that. We'll do that. Save. We'll call this encode binary columns. And we will have this depend on extract. It's this one. I just don't have a name properly. Now let's run it. Ta-da! Encoded. Now finally, we want to encode our string columns. Okay, let's add this. Impute text columns. Yep, we want to do that. Now this might be a little crazy because there's a ton of columns. I just won't run that actually. Okay, cool. So now we have that. Let's do encode text columns. Perfect. Now we have our whole data transformation pipeline. Good. Let's execute it. Make sure it's running. So go bam. These run in parallel. Okay, it's going. So now let's go ahead and train our model. We can go on and create a data exporter. Now the data exporter can do many different things. It can, you can create a data exporter block that saves your data set somewhere. It can you can write it back to your data warehouse, save it to a local disk, upload it to S3, and or even train a model in there, and then export that model to disk or export that model to your online inference. Okay, so first let's have this depend on several blocks. We'll want to get it from this encoder to this encoder, and the numbers are already encoded. So we'll inherit from those three. Great. Now in this block, what do we want to do? Let's first call it save, train, and test set. So I'm overly complicating this, but I want to just show the different steps. So here in this block, I'm just going to take all three data sets from these three blocks, and then I'm going to save it. I'm going to split the data and then save it to disk so that I can have other people use it, or maybe I want to stop here. Maybe I'm just building the data pipelines to save that data. So I'm going to do that. Okay, let's run it. Awesome. It ran successfully. And perfect. So next is, let's go ahead and, so look, basically what I did was I took the three data frames from 1, 2, 3, I looped through it, I merged them all together, and then I created the label column to survive, and then I split it, right? So I have the training set, the test set, and I have the labels for each one, and I saved it as a CSV file to disk. So then I can add another one. Again, this is over complicating it, but it's for demonstration purposes. Let me create one called train model and save model. So this one, as you can tell, it will load that data from disk. We're just going to use a logistic regression model. You could use whatever model you want because you load all your dependencies from a requirements file. So then what it's doing is loading the training set, instantiating the model, training it, then it's saving the model to disk. So let's run this. Cool, look, save the model. Bam. Now finally, last one, let's again, first actually I have to depend on this or else they'll just all run in parallel. Okay, so last one, let's actually prove out that we can load the model from disk and we can score it on the training set. So this one will depend on this. So let's depend on this one. Then we'll call it load model and score on test set. Very descriptive names. Great. So see, it's loading the test set from disk. It's loading the model from disk. It's predicting on the test set, and then it is scoring it. All right. Ta-da! So 70% accuracy. We can improve it, but this is good for now. So let's go ahead and let's do some, let's commit this code, okay? So actually, let me stash the code. I'm checking out, I'm pulling master, and then git stash. Okay, so I'm gonna create a new branch called model train, okay? Then I'm gonna add all this code, and then I'm gonna commit it, training model. All right, now let's go ahead and let's check, let's do some code review. So we got a PR here. Awesome. Okay, let's go through this code. 7 files changed. Let's look at it. All right. So I got some load model. Okay, easy to review. Got this, cool. Look how easy this is to review. My goodness. Awesome. I can quickly just stamp it. Thumbs up. Time to merge. Cool. Thank you for reviewing my PR. Let's go ahead and merge this. Great. Now I just finished building that pipeline, and I got approval from the team. It's merged. How are we going to run it now? So that was all on my local computer, right? Now it must be a pain to get this into production. So you think, but let me show you how easy it is. So let me go ahead and share my other screen. So I'm going to share, let's see, my terminal. Okay. You can see my terminal? I think you can. Let me see if I can zoom in. I can. Awesome. So here I'm SSH into my server, my online server, pipeline, orchestrator, wherever.
Can you zoom in a little bit more?
Yeah.
Just for those of us that are a little blind. There we go. Yeah, that's nice.
Is that good?
Yeah, sweet.
Awesome. So here I got, I'm going to CD into my MLOps demo. I'm going to get cool origin master. Awesome. I pulled all that data. Okay, you can see I have my exporters, I have my transformers, I have my loaders. Okay, whoops, ignore that. Now, all I have to do is do Mage run. I named the pipeline I named the project. There's multiple projects on this box, so I'm gonna use the MLOps demo project, and I can have multiple pipelines in a single project. What was our pipeline? It was called Titanic Survivors. All right, let's run it. Oh, look at that. Done, 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 done. Awesome. Okay, so these are done, but let's confirm. Trust but verify, like they say. So let's go ahead. Oh, look at this. It created our training set, our test set, our finalized model, and it even went to print it somewhere, right? Oh, right here, accuracy. 79% accuracy. Look how easy that was. I didn't have to do anything. Just one line. Well, of course, I had to do a pip install of the requirements file, because you can define the requirements file in here. So let me just show you real quick. So all I have to do is install those dependencies and then run that Mage run command. And now I have my pipeline. I can run it in any environment, modular code, reusable code. And so that concludes the demo. I'd love to take some questions, answer some questions, or hear people's thoughts.
Yeah, that was very cool, very fast, very cool. I think that we should take a little bit of time and go back into certain sections, kind of dive into that notebook a little bit. But high level, I mean, that was incredible. This is a really, really cool tool. And like you said, it's all open source, which is awesome. Very cool, because we were looking at this tool a couple weeks ago together, and the amount that it's changed just in a couple weeks has been kind of amazing. But I think just to start, can you share your screen again? And
yes,
we can kind of walk through that notebook.
Yes. Let me share screen.
Cool.
Window. Can you see? Is it shared?
Yep, I got you.
Awesome.
Now it's shared. Yeah. Cool. Okay, so I have a couple questions. I'm sure Demetrius does as well. But just to start, you started by saying that you guys don't like to call yourselves a notebook. We're looking at a notebook. What are we actually looking at? Like, what is this? Where does it fit in the pipeline? If I'm in love with Jupyter, as me and everybody else are, how do we consider where this fits in our system?
Yes, good question. So if you, and we don't want to replace notebooks, they're very, very great at what they do. And what they're good for is data analysis, exploration, sharing notebooks, presenting it, all that, and creating all these visualizations, that interactivity. But the moment you know what you want to do, and you actually want to take your work and put it in production, you want to take your work, you want to build something that impacts your users or runs on a regular basis, that needs to be versioned, needs to be code reviewed, and maybe iterated on, maintained, and evolved, then you want to switch to using something like Mage. And why is because you do get that interactivity of a notebook, right? I can even create these throwaway scratch pads, write anything in here. I can even just do some, matplotlib stuff right here. I gotta import that later, but I haven't imported that. But you can install different libraries. You can also share this with friends and things like that. But then where this differentiates is the ability to really modularize your code, to separate them, to write reusable code as well. And so what it does is it helps enforce. Now, it doesn't try to be too strict. We want to still make it an easy coding experience for you, but we do help guide in terms of code separation, right? The solid principles in software engineering. And so we help with that. We're bringing good software engineering, good data engineering practices into data science, because what we've heard from our users and community, that one of the biggest pain points is taking the code that you wrote in your notebook, your awesome, amazing modeling and data transformation code, and taking it and going through your notebook, taking out scripts, parts of it, writing scripts in a text editor, committing that, and trying to get that into production. And so we wanted to combine the nice experience of writing that code, and exploring that data, building those pipelines, but also make it so that you don't have to pull your hair out just to copy that code and put it into production and run in production.
Yeah. And on that note of interoperability, because you're talking about like the core here that I'm seeing is it's coming, like you kind of said, after your notebooks, before your production, and this can kind of get you to that pipeline state with this kind of really simplistic metadata scheme. I'm assuming, based on just looking at the pull request, that these are just files with some JSON, and you generate this notebook, but nothing is stored in any JSON way in terms of the notebook. It's all stored in files. So my follow-up there is, for example, you have a pipeline here called, well, so help me understand the structure on the left side. You have something called MLOps demo, which I don't think is the pipeline. I think MLOps demo is the repo.
Yes.
But you have a folder called pipelines. And so maybe this is actually helping me right here. What my question was, but now I'm seeing is that as you're building new pipelines, it's actually quite normal standard coding practices to grab your other transformations and your other data loaders, because they're all at the top level. You could even grab your scratch pad. So every notebook, based on its tagging, is stored in a folder. This whole thing creates one repo. And so the idea here, correct me if I'm wrong, is that a customer or somebody using this would create N pipelines in one GitHub repo, and all of those pipelines can share all of their components throughout the entire stack.
Exactly. Yes. Yep. And that's why we built this in a reusable way. So now the next pipeline I create, or my teammate creates, can reuse my impute number columns, my encode text columns. I can reuse yours as well. And it only requires these top level folders, but underneath, I can start actually partitioning even more. Maybe I have under my transformers, imputers, encoders, or like enrichment, or I can split it up by team as well. So you have the liberty of organizing a bit more than that. As long as it follows just these high levels, then the pipelines can load from there. It can execute the code from there. We can search from there as well.
What are those pipeline files? Are we looking at the right side, the visualization of some like JSON or metadata file?
Yes, very, very, very sharp eye. So let's go ahead and take a look. It's presented, it's actually a folder, but it's presented not as a folder, just because when you interact with it, there's really nothing that you need to do to it. So we simplify it from a visual perspective, but let's dive into it. It is a folder. Every pipeline is a folder, and it just has a YAML file. That YAML file is the one that links these files, these other Py files, to the notebook and also the dependency between them. But they're pretty simple YAML files. Let's take a look. So you see here, it shows you all the blocks, right, by UUI, by the ID of it, the status, upstream, etc.
That's awesome. Demetrius, I know I cut you off if you had a question just there.
Well, it's perfect because that's what I wanted to dive into a little more, like how this gets committed and also what you're looking to do next with the tool. Like, where's it going with this? I imagine there's a lot that you can do and a lot of places you can go.
Yes, I'm glad you asked. So there's a lot of amazing things that we have up on the pipeline. So, you know, we right now it runs on your local machine. We're working on making sure that it runs really easily on your own cloud resources. We're also working on making sure it works really well. It scales on very, very large data sets. So if you're working with out-of-memory data sets on your local machine, or if you're running in the cloud, working with PySpark or your Spark cluster, also being, we have some new functionality that makes it even easier to do really, really straightforward things like loading data. Lots of folks load data from Snowflake, Redshift, all those things. So when you add a data loader block, there's templates for that. Also, what I showed you, imputing, encoding, there's a lot of feature engineering or feature extraction techniques that are very, very simple and easy to do, but it just takes a lot of boilerplate code. So adding what we call quick actions to that as well. We don't have autocomplete yet, but what's amazing about this editor is that it doesn't do everything, okay? It does one thing or a few things very, very well. It's very focused on the singular data set or multiple data sets, right, in one. So it's very data centric. So our autocomplete, our user experience is very tailored and centered around that. You see how we have these tables, we have reports and graphs. These are, think of it as primitives or first-class citizens. They're not an afterthought. You don't build a chart like maybe optionally. It comes with it. And so the whole experience is around that. So the autocomplete, the suggestions we can provide is all around the data. Now, another really big thing that we have is right now, we have this, it's very opinionated in terms of the charts and reports it shows you, but we have what upcoming is a way for you to actually set your own charts, right? You just choose the chart type you want. We have many different chart types and you can easily add to them. It's in React, so lots of easy examples. You can add your own chart types and you can then customize your workspace to say, you know, I don't care about data completion. All I care about is standard deviation for all my number columns. So then I can actually choose, okay, I'm going to choose a function that takes any block, takes the standard deviation and displays a box plot, hypothetically. And I can pin it to my workspace. So now any pipeline I go to, any data I load, I can see that box plot. So it's a very customizable data-centric editor aspect of it. So there's lots of things coming down the pipeline, no pun intended. We're really excited about this.
Are those reports dynamic? So if you add another transformer on the left side and you run that transformer and you link it to the pipeline, does that chart update?
Yes, it does. So each of these, every single time you click on a different block. So this is really awesome too. You ever go to Notebook and you're transforming a single data frame and you have to like name the different data frames, or sometimes you overwrite it. Well, there's none of that here. You see how I clicked on the data loader, the very top
That's
one.
awesome.
You see all this data, right? Okay, then remember I extracted the number columns. Okay, here's all the reports and data for this block, for all the text columns, for all the binary columns. So each one maintains its state and memory for that block. And if let's say, you know, I decided to do this instead, great, updates.
And so to understand this piece, if you create a transformer cell and then you create another transformer cell below it, does it know about the one previous? Like, can you access variables created from the one above, or do you have to link it to be able to access those variables?
Good question. So I just added a transformer block, right? One of the colored blocks. You have to link it to something to get. So let's say I'm going to do these three, hypothetically. Now I have access to these three return or data frames, and I access it as a
How did you get
that
little hidden thing there?
Oh, oh, you see this? I clicked this. I click on blocks I click on different blocks right here, and then it just auto tells me. It's just it's
And
a
that's
helper.
just
It
always
tells me.
that's just always there in the cell.
Yes. Yep.
Wow,
Well,
that's
it's not in the
amazing.
code. See, this is the
Right,
code. This is
right,
what gets submitted. This is just a helper. Now,
right.
this is if I want to block. Let's say I'm not ready to build a block. I just want to play around. Okay, I'm in a scratch pad. So the thing about what's unique about Scratchpad is it's just literally like a Scratchpad throwaway, right? So I can actually click on this variables and I can look at here. Let's say I wanted to access the extract text columns. So then I can go to extract text columns, copy that, run. There, see, I accessed that data frame from that block. Maybe I want to extract the number columns too. Okay, so
How did you know? Wait, how did you? Oh.
Oh, there's this tab called variables on the right side, and it'll tell me how to access the variable. There could be one or multiple variables that are defined within each of these other blocks. So how do I get it out of there? You can just use this function.
So that's pipeline step name variable name in terms of the parameters. Got it.
Yep.
Wow. And so feasibly seeing as you're putting in a pipeline, you could access from a different pipeline.
Yes, exactly. Yep.
Incredible.
So
Demetrius,
I
you
want to
formulating
know.
a question there?
Yeah, dude. This is really cool stuff. First of all, I'm just gonna say that, put that out there. Ben and I both were chatting while you were giving the presentation, and we were like, "Whoa, this changes things a little bit." We're big fans already.
Thank you.
And I want to know, like, as you're looking at this piece of the puzzle, how does it play with other pieces of the puzzle? Like, if I want to have something like later, eventually, I'm going to want to do more stuff with my data, right? And my models and whatever. Like, how do you see yourself fitting in the stack?
Yes,
Yeah.
great question. And so how we see the stack is there's roughly 4 parts. And of course, each part you can break it down even more and more and more. So there's the data management side, you got your feature stores, you got your data warehouses, all that. And then you have your prototyping stage, which is where you have your IDEs, where you try out models, where you build models, etc. Then you have your lifecycle management, where you store all your training sessions, you store all your metrics, your artifacts, versioning, retraining, etc. Then you have your inference, where you do your online inference or you do your offline batch inference and you serve that. So where we fit in is the prototyping aspect of it. And so, you have your data management. A lot of folks have their own data management side set up, right? We're not trying to replace any of that. This hooks into that because you load your data from your data management, from your feature store, wherever. And then now you could also optionally write back to it if you want. You have your data exporter down here. I wrote to disk, but you can just write back to your data warehouse, right? So this can write back, this can transform back. Now, in terms of modeling and training, yes, you can train it on your own resources, or if you have a different service, let's say you use SageMaker, you can make an API call here, send your model over there, and train it over there, and then pull that model back if you want. Or if you want to store it in S3, you can just export your model and store it in S3 there. And then for inference, right? So this is, if you want inference, well, great. Run this pipeline in your cloud or on your own resources. And by the way, you can use our pipeline engine, or we can help. What's upcoming is we can auto produce Airflow operators as well. So we can integrate with your existing data orchestration. Now, if you want inference, great. Just run this pipeline, train that model, save the model, and then in your inference pipeline, just load that model wherever you exported it to. So we fit right into that stack in the middle where you know what you're about to do. You got your data, you know where to load it, and you're ready to just explore and train.
Yeah, I like that. It's that exploratory analysis and figuring things out and then running with it. So one question from the chat that I think is an awesome one is you've been doing a lot of magic with all these different blocks, but what are all the blocks that we have options to use? What can we do with these blocks? Like, what are the different blocks that we can use?
Yes, good question. So at a very high level, there are 4 kinds of blocks. And The Scratchpad one is, just think of it as it's equivalent to a cell in a Jupyter notebook. You can literally do anything in there. I can pip install things, right? I can pip install matplotlib. I can look at current working directory, right? So I can do anything in these cells. I can print out. I can even run some matplotlib charts as well. So I can do something like this, right? Like, awesome. Now, once you play around with that Scratchpad, the first thing you want to do is create a data loader block. Now, you can literally write any code in here. Now, soon, I shared before, what's upcoming is templates. Let's say you want to load something from MySQL. You would click add data loader and choose MySQL, and we'll fill in boilerplate for you. Import MySQL.connector and all that boilerplate. All you got to do is fill in your host, port, password, and we have a way to write secrets so it doesn't get decommitted or anything like that. And so you load your data. You can load data multiple times if you want. And then the bulk of everything is these transformer blocks. Now, these transformer blocks, they operate on input data, so you have to link it to something. What's great about this is if you are operating on single columns or 1 or 2, 3 columns, we'll be able to tell whether or not we can run them in parallel. So when you so of course, if you're on your local machine, if you don't have a multi-core, might not work. But in the cloud or on different resources, we can detect which ones are in parallel. So you see these 3 are parallel, they don't depend on each other. We can run them in parallel, and then we can run the other one sequentially. So most of your work will be done in transformer block. And again, you can do anything in this block. We don't want to be too prescriptive in any of these blocks. We don't want to say you can only do this, you can only do that. Technically, you can load your data in these blocks too if you really want, right? But we don't want to be too prescriptive. And finally, you have your data exporter. You can, again, it depends on something, but it doesn't return anything. So again, this is typically what you do at the end of it. And theoretically, you could still load your data, save it to disk, and then load it in another block as well, of course, right? Again, we don't want to be too prescriptive, but with these 3 blocks, you can think of an end-to-end pipeline. The top level, load data. The middle blob area, transform a bunch of stuff. And the terminal nodes, export it somewhere.
That's really cool. I have 2 questions, one from the audience, one from myself. One question is, does it have support for things like unstructured data? And to expand on that, in case that's not what the person meant, all the visualizations here are definitely for structured data. Obviously, you can do anything you want in the notebook cells to transform your data. How would that look if you're creating unstructured data in your system? If, for example, you're not using a pandas data frame?
Yes, very good question. Yes, so it does support unstructured data, and so you can literally write any code in here. Now, we first initially started off with just pandas data frame. Just a lot of our existing users were using tabular data. Now, remember I shared earlier about this right side. It's very opinionated right now, but we're changing it to be more of you customize your own workspace. And so the types of reports and the types of charts that you would want to see, it comes out of the box we have some presets that come out of the box, but for someone who wants to work on audio data, image data, etc., you might have some different visualizations. And so what we're going to introduce soon is chart sources and chart presenters. So imagine a chart source is I have a data loader and it just loads an audio file. I can have a chart source that takes that audio file and splits it up into some sort of three-dimensional data set. And then I can have a presenter that simply plots it on like a 3D chart or something like that. I can pin it to my workspace. So now every single time I create a new block, I can visualize that output. So first, initially, it's just on tabular data, but we have on our roadmap to support more and more different data types. Absolutely.
That's very cool. And so it sort of leads into another question I have, or 2 other questions that I have. One of which is that it seems broadly speaking that you're creating an extremely unopinionated pipeline creation tool, right? Users can create, design, architect full pipelines, and it's really simple. They can run them anywhere. You have your requirements that people can set dependencies. But what's not in this tool, and because it's doing so much, it has to do specific things. What's not in here, for example, is an orchestrator. So let's say I'm a data engineer and I'm using Prefect or I'm using Airflow. How do I take this and run it with them in ways that gives me insights into my pipeline? Like certainly I could in Prefect run pipeline.py and run that, but that's not going to give me information.
Yes.
How do you fit in with orchestration tools?
Yes, great question. And so, I was at Airbnb, so huge, tons of knowledge, worked on Airflow, everything like that. So believe in all of those and not trying to replace those. We actually work with them. So for the first one is Airflow. Now you can, like you said, you can create a single task in your DAG that executes this entire pipeline. And we have ways of alerting, monitoring, etc. But then, like you said, you don't get, you in the Airflow world, you cannot see like which particular part in this tree failed. So there's another part where we create those tasks in your DAG for you. And so that's how then you can start seeing, okay, this is a task in your DAG, this is a task in the same DAG, task, and that's the DAG that you've created. So that's the integration that we have. And so we're doing it one at a time. First, we're going to target the biggest one, which is Airflow, and go next to things like Prefect and other orchestration type tools, and integrate very, very deeply with those.
So that's actually that's really interesting. And so I have a specific question for Prefect, because, for example, Prefect is in many ways simpler than Airflow in creating those pipelines, right? You can very simply just at task for your tasks and at flow for your main function. Could I just, since these are just files, they're not notebooks, could I just tag my data loader with an at task, like wrap your at data loader with a task decorator, wrap all your transformations with task decorators, run whatever the main function is to run your pipeline with a flow decorator, and just get it in Airflow by default? Would that work?
It actually does, yes, because when the architecture design for all of this is each of these files can be ran in outside of this. Like, it's not that we have this file, you should stand alone as a Python file outside of this entire framework. So you can, even in your terminal that has nothing installed, you should be able to run Python, name the file and run it, and it should not break at all. So absolutely, you can take this and then adapt it very, very easily in the Prefect environment or in the Prefect world with exactly what you just said.
That's really, really cool. That makes a lot of sense.
Yep, it's all really cool.
Small follow-up for, you're talking about data, and you mentioned Spark a little bit. When you are, especially if you're running things in parallel, you're generating a lot of data. Pandas data frames obviously don't scale forever. One question is, how is data passed between tasks that are dependent? Like, how is that Pandas data frame passed? And the second one is, if you are running with Spark and you have dependent tasks, where is that Spark data frame where does it occur in the for example, you have a task, it branches, it comes back. Like, where is that Spark data frame existing in the meantime?
Yes, good question. So if you're running this locally, or if you're running it on in the pipeline locally on a local machine or in your cloud resources, it is passing it via in memory. Now, if you're using Spark, PySpark, things like that, it is in memory. But if it can't fit in memory, then we save it back to if you have S3 or if you have another persistent storage that we can, like a data lake that we can save temporarily to, it would store it there and then load it from there.
Would you do that? Is there some configuration that's set up there that you would write and then read?
Yes. And so that's that's on our roadmap, is working and integrating with your cloud, which would require you to provide a few IAM policies for Mage, the pipeline, to be able to do those things.
Interesting. And so that gets into a lot of concurrency questions, but I don't think that this is the time for those types of questions. That's really, really cool. That's an awesome workflow.
Yep.
Sweet. Well, if we don't have any more questions from the audience, so that's what we've got. I don't think there's any more questions, right? That's it. This has been awesome, dude.
Thank you so much for having me. Super, super excited to be here. Thank you so much. And, thank you everyone for coming. I'd love to keep chatting with folks as well. So please, check out our repo and join our Slack. We're always on there, and can't wait to see more of you.
There
Awesome.
we go.
Good luck.
All
Thank you
right,
so much.
y'all.
Yeah.
We'll see you later. Have a great
Bye-bye.
day.
Have a good day.